Okay, so hello, and today I am going to be talking about my interpretation of IPv6 and how I would subnet in IPv6, or how I learned to do it and understand it, right? So first of all, what is IPv6? IPv6, also known as Internet Protocol version 6, is the newest version of Internet Protocol, which allows communication to transfer over a network and provide, as well as providing unique addresses to internet-enabled devices. IPv6 was created to deal with the long-anticipated problem of IPv4 address exhaustion, right? And here we can see the differences between IPv4 and IPv6. So IPv4, as we can see, the IP address is 32 bits in length, right? And you can have up to 4.3 billion IP addresses. And here we have an example of an IP address, right? Compared to IPv6, which has 128-bit address length, and you can have approximately 340 undecillion IP addresses. Here's an example of an IPv6 address. As you can see, in comparison, it is a big difference. Next, we have format and abbreviations. An IPv6 address can be abbreviated, ensuring that certain rules are taken into consideration. The rules are as follows. Here we have an example of an IPv6 address. I just made it like this so that we can see all of the rules take place with one IPv6 address. So if there's a string of zeros, you can remove them. However, you can only do this once, as you can only have one double colon, right? So as we can see here, I highlighted some zeros in red, right? And you can remove those and just insert a double colon. Easy, simple, but you could only do it once. Only one double colon in the IPv6 address. Rule 2. If you have an hex step with 4 zeros, then you can remove those and leave a single zero. Most IPv6 enabled devices will automatically add the 3 remaining zeros. So here we have an example. Let's say you have a hex step with 4 zeros. You can just remove it. Oops. You can just remove it as seen here and just replace it with 1 0, right? To make it shorter. Because as I said in Rule 2, most IPv6 enabled devices automatically add the 3 zeros, so there's no need for us to input the full 4 zeros. Rule 3. Leading zeros can also be removed. So as you can see here, we have leading zeros in 3 hex steps, right? So in the first hex step, you can just remove those 3 zeros and you'll get 1, right? Second one, you can just remove those and you get 2, right? And then third one, you can remove that and you just get 3. And as you can see, there's a big difference in this address compared to the first address that we see in Rule 1 right here, right? Look at the difference. Alright, next we're going on to hexadecimal to binary. So each number that you see in an IPv6 address is in hexadecimal, right? So meaning, what does that mean? Each one of these digits here is 4 bits. And as you can see, I have a chart right up there to show you why we convert it. So 2 is 0010, 0 is 0000, 4 is 0100, 1 is 0001. And I put these lines in here to just make it easier to divide up the zeros. But as you continue to translate from binary to hexadecimal, vice versa, you will see that these basically mean the same thing, right? Now let's move on to IPv6 subnetting. Okay, so now we're going to get right into the subnetting. Okay, so first things first, let's look at the parts of a IPv6 subnetting address. The first 48 bits is the global unicast address. 16 bits is the subnet ID, right? And the last 64 bits is the interface ID. Now let's see how this translates over onto our subnetting calculator. So this will be our global unicast address. This will be our subnet ID, and the rest is the interface ID, right? So as we let's start subnetting. So here we have the IPv6 address. We have the IP address 20010db8 FFFF 222BB 1128 E30B AF323893, right? And in the fourth hex stack here is where all of this subnetting is going to be taking place, and it's good. It's not necessary to do it in binary, as if it's in /64 it can be easily subnetted. However, it is best to subnet in binary and do the ANDing, because if you get a network prefix link that is not only 4-bit boundary, ANDing in binary is necessary. It is not optional, it is necessary. You need to do it, because let me show you why. So here we have our IP address, and so here we have our IP address, and it is a 64. It has a 64-bit link prefix, right? And it is only 4-bit boundary. So subnetting this, as you can see here, we did the ANDing here, right? And we get our IPv6 address and our network. However, let's try and then let's get another example on the 4-bit boundary, right? So if the next 4-bit boundary is going to put 0, and then this is going to change to a /60, right? And there we have it, and then it changed, as you can see. So now it is no longer 22BB but 22BO. The IPv6 network changed from 20010db8 FFFF 22BB to 20010db8 FFFF 22BO. So now let's try with a value that is not only 4-bit boundary or range, right? So let's do /61. And for /61, then this will turn into 8, because as you know, when you are counting the bits, right, it goes from 8, 4 to 1. So we're gonna turn on this 1 bit here, so it'll, right, and we change it to 8, 1. And now the value lies between this B right here, right, and the network has changed to 22B8. So now, right, it is no longer on the 4-bit boundary, but it is somewhere in between the B, and we cannot slice open the B and find the in between of the B, right? So what we have to do is that we have to use binary to AND it, so that we get a more accurate network address. Okay, and that's it.